Yeah, don't write anything down on a sheet of paper. This packet's coming to you. All right. So we want to integrate trig functions, and we've established that integration is related to differentiation. How?
It's the opposite.
It's the opposite. Okay. So if I want to know how to integrate stuff, I need to remember how to take the derivative of stuff. Because if I know the derivative, then I know the reverse has to be integration.
Yes.
Everybody buy that?
Yes.
So derivative of sine is cosine. Derivative of cosine, negative sine. Tangent. All right, cotangent.
Cosecant times something.
It's negative cosecant squared. Cosecant. Good night. You guys were so strong on these.
Yeah, that's a good club. It goes into cotangent.
All right, negative cosecant cotangent, which means secant is secant tangent. There it is. So, if the derivative is going from here to there, then that means from here to there is integration. Everybody with me? So it's backwards. So if I'm going to integrate sine, I'm going to get
Negative.
you tell me. Negative cosine. Okay. Integrate cosine. Positive sine. Integrate secant squared. Tangent. Integrate cosecant squared. Negative cotangent. Integrate cosecant cotangent. Negative cosecant. And integrate secant tangent. Secant. Okay, and what am I forgetting on all 6 of those? Plus C. I named my plus C. Not yet, but we will get there. There's something else we need to learn, and then once we know that, then we'll apply that.
Right. When do we start you for the
Late March.
What are we doing
So whenever we get done learning new stuff, are we gonna have like tests?
Oh, I'm.
How are we gonna agree?
We're just working. So by the end of
March, our grades are set this week.
well, I mean, if you don't participate, then that'll change.
What?
If you don't participate, then they will drop. If you don't participate in our reviews, they will drop.
So maybe
Which one did I give you?
I think he gave us a worksheet.
Yeah, I gave you the assignment.
Well, gosh
You
darn.
needed it anyway.
So wait, what if we do participate? Our grade won't go up though.
What?
Confusion what?
I feel like you should take a break. Take a blood off your feet and get some blood.
Yeah, I agree.
All right, now let me give you something to help you remember what's negative and what's positive. Okay, and let's remember back to when we were taking the derivative. Okay, how did we decide what ended up being negative, Ivan? If it started with a C and I took the derivative, my answer was negative. Okay, so if you notice cosine's right here, starts with a C, the derivative to it was negative.
110, 118.
Cotangent starts with a C, derivative is negative. Cosecant starts with a C, derivative is negative. So can someone, besides Ivan, Roshan, tell me what the trick is over there? If my answer starts with a C, it's negative. Okay? So here, it matters what you start with. Here, it matters what you end up with. Okay? That's the difference. Okay? That's how you tell what needs to be negative, what needs to be positive. Ended up with a C, it's negative. Ended up with a C, it's negative. Ended up with a C, we're negative. Okay? Everybody have these before I clear them? So let's run through some of these. Alright, so I integrate t squared minus sine of t. What do I get when I integrate t squared?
1, 2, 3, yeah.
Okay, you can write it as one of two ways. 1/3 t cubed or t cubed over 3. Either way, same thing. Okay, then I have minus, and I want to integrate sine. What do I get when I integrate sine?
Negative cosine.
Negative cosine. Okay, and don't forget the c. Okay, and again, why is it a negative cosine?
Because the
Answer starts with the c. And obviously that double negative makes it positive. So we're looking at 1/3 times t cubed plus cosine plus c. Yes.
Would the c be negative?
No. C is always positive.
Okay.
C is always going to be positive. Good on that? Okay, next one. Secant of y times tangent of y minus secant of y dy.
Would you find what how to do it, or you integrate the function first and then distribute it?
Well, do I know how to integrate secant? Is that one of the things I know how to do? No, so that means I got to do something. So let's multiply it out and see what I get. Okay, so if I multiply it out, I get secant y tangent y minus secant y squared. Or secant squared y. Okay, do I know how to integrate secant tangent? Yes, what does it turn into? Secant. Do I know how to integrate secant squared? Yes, what does it turn into? Tangent.
Do you add a C for each one, or do you
No,
just-
you only need one c. So we end up with secant y plus tangent. Good question. Anytime you're integrating, okay, sometimes we're going to integrate both sides of the equation, which you'll see here in a little bit. But anytime you're integrating, you only need to add one c. You never need to add more than one c. Yes.
Would tangent be negative?
No. Oh yeah, it would. Sorry. I didn't know that. I didn't recognize that the negative was already in there. Thank you. Question on that one? Alright, integrate cosine over 1 minus cosine squared. Cosine over 1 minus cosine squared. What do you guys think? Need to replace 1 minus cosine squared with sine squared.
That's like last year's stuff.
It is. It's awesome. Okay, somebody besides Ryan and Ivan tell me what's going on here. Where does sine squared come from? What'd you say?
That paper that you gave us last year.
It's a trig identity. More specifically, it's a Pythagorean identity. You've got a Pythagorean identity that says sine squared is equal to 1 minus cosine squared. So I took the 1 minus cosine squared out. I put sine squared in there. Very good. All right, what else?
I wish I had a paper too.
Ethan?
Would it be cotangent sine x?
Cotangent, you're close.
Or 1 over sine x?
Close.
Cotangent over sine?
Well, what can I integrate?
Would you change it to cosecant?
Do we code?
You're
That's
close.
cosine times cosecant squared.
You're close.
I feel like I'm right on it.
All right, Ryan. There we go.
Oh, because 1 over sine is equal to cosecant.
All right, so the cosine over one of the sines gives me cotangent. And then I have a sine left on the bottom. If I have a sine on the bottom, it's the same thing as having a cosecant on the top. What identity was I using there? I used two different types of identities there. What are those? Reciprocal. Somebody else has to give me the other one. quotient.
Oh, it is?
It is quotient.
Okay.
So when you have sine over cosine or cosine over sine, you're using a quotient identity. When you have 1 over one of the trig functions, you're using a reciprocal identity. So 1 over sine is the same thing as cosecant. Cosine over sine is the same thing as cotangent. Yes?
We've done what I said, and then like you split the two, and so then you like
Yes.
you can do that.
Yep.
Okay.
I think. So what did you say?
Like
Cosine times cosecant squared? Yes.
And then split it.
Alright, so if I integrate this, I get
Whatever was negative cosecant.
negative cosecant. Again, why is it negative?
It starts with C.
I ended up with something that starts with a C. Alright, so there is integrating trig functions. Okay, it's pretty much you got some more stuff to memorize is what's going on there. Actually, you don't have more stuff to memorize. Why do you not have more stuff to memorize? Because you should already have it memorized as the derivative. Okay, now you just got to now you're just going from the right side. What's on the right side can turn into what's on the left side.
But the stuff from last year was in the
Okay, but if you don't have the stuff on the left side memorized, then you're in trouble. You need to start memorizing some stuff. Okay,
Can you give us
and
those papers again?
say it again.
Can you give us those papers again?
We got last year.
Yeah.
With all the identities,
Yeah.
yeah, I can do that.
Yes.
Okay, now if you don't have something that you can integrate, what do you need to do? Right, we need to use our identities to change it into something that we can integrate. Okay, so you have a fixed list of stuff you can integrate with regards to trig stuff. Okay, there's not a infinite number of stuff you can integrate. So if it's not something you can integrate, then change it into something you can. All right, next thing we want to look at is solving differential equations. We kind of did this the other day. Okay, I have dy over dx equals 2 times x minus 1, and I have the point 32. You guys remember doing this the other day?
When you plug in 3.
No. So nobody has anything for me to go off of? Ryan, what we got?
You should multiply by dx to get dy.
Okay. So I have dy. I'm going to go ahead and distribute the 2, make it 2x minus 2, and then I have dx. Okay, differential equations, the first thing you're going to do is separate. So I move that dx over to the other side. Okay, this is something we did last week. Okay, then somebody else, what do we do next? Elias, what do we do next? Well, I don't want dy's and dx's in my problem, so what do we do to get rid of dy's and dx's? What? I do the thing. What's it called? Integrate. So I need to integrate. Okay, if I integrate dy, what do I get? I get y. Okay, integrate 2x. Yeah, it would be 2x squared over 2, which just turns into x squared. Integrate 2, 2x, and then don't forget the plus c.
So anytime you have a normal or a constant, like a normal base number, you'll add a variable to it.
Yes. Whenever you have a constant and you're integrating whatever this is, you add it
So
to
if it
it.
was d to the m, you're going to put 2 in.
I put 2 in, that's correct. Okay, technically what's in front of this dy? A 1 is. So I just stuck a 1 or a y on that 1. Yes.
So are we integrating negative 2 and dx separately, or are we doing that together?
The d you're not integrating dx.
Okay.
What happened to dx?
This goes back to the videos from last week.
See, that just tells you what you're integrating.
Yes. This is your variable of integration. This tells you what you just said. That tells you what to put here, is what that does. That's its function.
So it's kind of irrelevant to that.
Yes. Once you integrate, you don't need it anymore. Okay. All right. Now, this is where, even though you guys are acting like you didn't see this problem last week, this is where the problem changes from last week to this week. Okay. Because last week I didn't have this point right here. This point right here is going to allow me to find my constant. Okay, so what do we do to find our constant? Plug it in. So 2 equals 3 squared minus 2 times 3 plus c. So I have 2 equals, this is 9 minus 6, which is 3. And I get c to be negative 1. So I found my constant of integration. I want to plug it back in. And I have solved that differential equation. So separate, integrate, plug in, find your constant, then plug your constant back in. We've got our solution. What should happen if I take the derivative of this? It should give me that. All right. Last one. All right, g prime of x equals negative 1 over x squared, and our initial value is 1, 3. Our initial point is 1, 3. All right, talk to me about this one. What can I replace? What can I replace this with? Yeah. This is the same thing as dy over dx.
Does it matter if it's a d there, or does it have to be d?
It needs to be d.
So then multiply the dx over.
Multiply the dx over. Excuse me that.
A little squiggly line.
Integral.
Integral.
Okay. Integrate the left side and I get y. Okay, negative 1 over x squared is the same thing as negative 1 x to the negative 2. So I change the exponent, it turns into negative 1. And I divide by the negative 1, so we end up with 1 over x plus c. Okay, what's next? Plug in. So I plug in 1 and 3. So I get 3 equals 1 over 1 plus c. So that means c is 2. Plug my 2 back in. Now, since they did g prime, if I integrate g prime, what should I get? I should get g. So I'm going to put g in here. And g is going to be 1 over x plus 2. And I've solved that differential equation. Got it? How do we feel?
Pretty good.
Abby? Good? Abby? Elias? What'd you give me? Zach's big head was in the way. I got a big head too. Alright, remember again, when you're integrating trig functions, how do you determine what's negative? If your end result has a c, you got a negative. Alright, get to work.